All right, welcome to The Explainer. Today, we are diving into what is, without a doubt, the single greatest mystery in all of cosmology. It's the fact that almost everything we think of as the universe, well, it isn't. Everything we can see, touch, and measure is just a tiny, tiny fraction of what's really out there.
So let's just start with this number, 95%. That is how much of our entire universe is completely unaccounted for. It's missing from our theories, invisible to our instruments. It's just gone.
Yeah, you heard that right. Every star, every galaxy, every black hole, and planet, everything you've ever seen in a beautiful telescope image, all of that is crammed into the other 5%. It means the vast majority of reality is just hidden from us, basically in plain sight. So that begs the obvious question, right? Where is all this missing stuff? And that question launches us into a cosmic detective story. We've got the scene of the crime, the entire universe, and two major clues that point to what's really going on. Okay, let's follow our first big clue. And it comes from just watching how enormous things like entire galaxies behave. So we can look out into space, and we can actually see that galaxies are spinning. They look like these huge, majestic pinwheels in the sky. And that seems normal enough, right? But this is where the mystery really kicks in. See, based on all the stuff we can see, the stars, the gas, the dust, there just isn't enough gravity to hold these things together. The stars on the outer edges are moving so incredibly fast that they should be flung off into the cosmic void, kind of like water flying off a spinning tire. But here's the thing. They aren't flying apart. They're holding together perfectly. This observation makes absolutely no sense with our laws of gravity. Unless there's something else there. Something massive, and something totally invisible. And this was the exact question that had astronomers totally stumped. What could possibly be providing all of this extra gravitational glue? The only answer could be some kind of invisible substance with a whole lot of mass. Scientists gave it a name, dark matter. It's dark just because it doesn't interact with light at all. We can't see it, it doesn't reflect anything, but it has mass, and because it has mass, it has gravity. The best way to picture it is as a kind of invisible scaffolding that galaxies are built on, providing all that extra pull needed to keep them from flying apart. And we really owe a huge thank you to the astronomer Vera Rubin for this. It was her meticulous, painstaking work back in the 1970s, measuring exactly how fast these galaxies were spinning, that gave us the first undeniable evidence that this invisible matter had to be real. Okay, so that's one culprit identified, dark matter. But it only accounts for about a quarter of the missing stuff. So let's move on to our second clue, which points to something even stranger and way more powerful. So, ever since Edwin Hubble, we've known that the universe is expanding. And for most of the 20th century, the assumption was that all the gravity from all the matter in the universe would act like a brake, slowing that expansion down. Maybe, one day, it would even pull everything back together in what they called a big crunch. Then, 1998 happened, and two separate teams of scientists made a discovery that completely turned cosmology on its head. The universe wasn't slowing down at all. In fact, it was speeding up. The expansion was accelerating. This meant some mysterious force was actively pushing everything apart, and it was overwhelming gravity. It was so revolutionary, it won the Nobel Prize. So this sets up the ultimate cosmic tug-of-war. On one side, you have gravity, trying to pull all of space-time back together. On the other, you have this mysterious new force actively pushing everything apart. And the mind-blowing part, the push is winning. This mystery force was given the name dark energy. We think it might be a property of space itself. So as space expands, more of this energy just appears, causing the expansion to go even faster and faster. It's almost like a form of cosmic anti-gravity. So with our two main suspects, dark matter and dark energy, identified by their effects, we can finally complete the cosmic inventory. We can actually write down the recipe for our universe. So here it is. This is the recipe for everything. About 68% of it is dark energy, the force pushing everything apart. Another 27% is dark matter, that invisible scaffolding holding it all together. And that tiny, tiny 5% sliver at the end? That's us. That's every star, every planet, every person. Everything we've ever known is in that 5%. So, case closed, right? We found the missing 95%. Well, not exactly.
In solving one mystery, we've actually just uncovered a much, much deeper one.
And this is maybe the most crucial thing to understand here. Dark matter and dark energy are really just names. They're placeholders for our own ignorance. We can see what they do, we can measure their effects, but we have absolutely no idea what they are. We've just replaced one giant mystery with two even bigger ones that happen to rule the entire cosmos.
And trying to answer these questions is the absolute frontier of modern physics. What kind of particle makes up dark matter? What is the fundamental nature of dark energy? And maybe the biggest question of all, if this acceleration continues, will the universe end in a big rip, where everything, even atoms, gets torn apart? These are the questions that keep cosmologists up at night. You know, this whole journey really just proves how much we still have to learn. We thought we had a pretty good handle on reality, only to discover that 95% of it was completely hidden from us the whole time. It leaves you with a final and pretty humbling thought. If we missed all of that, what else are we missing right now?